And today's class is going to be one of the important concepts related to object-oriented programming. That is static, this, and super keywords. So this is one of the very important aspects in object-oriented programming. This is also there in other programming languages like Python, C. I'm not sure about the static, but this and super is there in almost all programming languages, whichever handle the objects. In Java, this is very critical. These three keywords are very critical for developing programs, writing programs, or developing applications. We don't develop the programs, we write the programs and we develop applications. So guys, whatever we have been discussing, it's not a discussion actually, it is a monologue. I am talking and you people are just listening. There is no discussion in any class. So whatever is getting transpired, okay, if at all any learning is happening here, so let me use this word transpire. If any transpiration is happening or transformation is happening through my classes, you may not be able to appreciate right now the amount of learning that is being transferred or transpired. But in future, I'm sure you will appreciate for learning this subject because everything is Java. Everything is Python is. I can actually show you a small animation how Python is leading today to the world. I'll see this video. Hello.
Yes, sir.
See here, I'm going to pass off this. If you see, this is actually starting of the, I mean, it should be somewhere around 2004 to 2012. So this video starts from, this animation starts from 2004. Here, left, right bottom, you can see the, year. And keep watching. See, the number one is Java, and the second is PHP, third is C, C++, fourth one JavaScript. Where is Python? Python is here, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth popular language in 2004. Okay, it was, I think, 2004. It is there right from 1990s. I don't remember exactly. In 2006 Hadoop came. 2006 Hadoop came. I think somewhere. I don't know. So, okay, anyway. So now keep watching this animation and see how these programming languages are shifting the places and how they, especially keep an eye on Python. 2005, 2006, 2007, 2008. You see, there is a major change. Somewhere in 2006, there was a major change. And then 2009, have an eye on Python. 2011, Python went up. C# went up. Python slowly, kind of. 2014, 15. See where will be Python. Python 2016. Now you see Python how it is moving. 2018, 2019, and 2020, 2021. So this is actually what I would like to show you. Okay. So why I'm talking this is actually I just wanted to. I mean, I was talking about the object-oriented programming, and but Java, though it came well later. Python came in which year? 1991. And 1996, Java. Though it came well later, but it became so popular because of the special trait of object-oriented programming. It was just object-oriented programming. That's all. It is just object. It belongs to, because in Python what happens? It is many. There are many things. Like it is though it is a general purpose programming language. It can be used as a script. It can be used for the object-oriented programming. It can be used for that, that the multi-paradigm nature of Python. People took, decades of time. So when it was released, 1991. So 1991 to 2020. Imagine. 2020, 1991 to let's take 1990 to 2020. 30 years. People took 30 years of time to understand the popularity of the multi-paradigm approach. So at first, the people did not understand, like, somebody used to talk about object-oriented programming, somebody used to talk about scripting, somebody used to talk, and I'm talking about Python. So whenever Python is under discussion, so one fellow talk about object orientation, one fellow talk about scripting, one fellow talk about procedures. This was highly confusing. That's why it was not adopted. It was not adopted. But Java, why people just, Java was also not successful. In the year it was first released, the very first when it was released. At first, when it was released, people opposed. Everybody said, "Oh, this is a backward language. I mean, we don't want this because it's just it's elegant, but so simple. Just to reduce to object. They don't want anything to be done. Just an object-oriented programming, and class and object. This is what is the philosophy behind Java. So people did not accept because by then, they are all, C was so popular, very, very popular. And Copal was already there, Fortran was there, and people didn't care. And that's, second release by the time Java appears, second version, two came, then everybody started looking at it. Oh, this is something is happening here. So these people are highly interesting, and it is so simple, and we don't need to. So that is actually too many things in brain. What happens, it corrupts. It corrupts our thought process. So it is always better to stick to a particular, aspect of that is what, many times I tell you, you can plan your future. This is all, everybody will be, every one of you and me, we have to adopt information systems. Right now, I think, I don't need to tell you, marketing, finance, HRM, operations, whatever, wherever. You may be a operational manager, you may be executive, you may be HR executive, or whatever you may be. But end of the day, it boils down to information systems. Your ability to use your understanding and ability to use the information systems is going to determine your job success. That is what. But in management, what happens? Most of the managers, they do deal. They're highly sufficient with Word and spreadsheets. So if you know spreadsheet, how to use spreadsheets, that's more than enough. For decades, we managed our offices using spreadsheets. Not even VBA. VBA is also not. But future is not like that. Future is in the hands of the people who are in industry. Skill matters. In industry, skill matters, but in academics, learning and scholarship matters. Scholarship means read, write, learn, reproduce knowledge, processing knowledge. In industry, nobody is interested in your knowledge. They are only interested how you are using your knowledge and create value. Like you have to convert your knowledge into money. So that is the most. If you have some IT knowledge, they want you to convert that IT knowledge into money, dollar. That is why we said data makes dollars. Data makes dollars. Today, data is. I think today morning I was reading one of the newsletters in business line. I think Hindustan Unilever. The CEO Mehta, he was telling to the media, like, we have three assets here. Number one, people. Number two, brand. Number three, data. And now the CEO is planning re-engineering, business re-engineering. They have abundant of data with them. Now, how best they can use that data for informed decisions. Like, decision is very critical, in business. Executives need to take decision. As a CEO, COO, CFO, CIO, these executives, they need to take decisions, and these decisions are very critical in business. So to take decisions, they need data and information. Data and information. So these are all things like, why I started talking, because object-oriented programming, though, Python is leading right now, so it was not once, but now today, as on today, people started liking Python traits, and it will continue to be there for some time. But Java is not inferior. I'm a Python man, so I'm not actually, frankly speaking, I'm not for Java. I love Java because it is so dynamic, simple, and widely used. Python was not widely used, but now things are changing. Even Python has got a couple of web frameworks like Django. I don't know the Django, whether it's Django, Flask, Bottle. So web development is also rising in Python communities. But as far as now, as of now, JavaScript was ruled JavaScript, jQuery, Angular, React, and today we got Vue, Express, Node. చాలా ఉన్నాయి ఇవన్నీ కూడా మీరు నేర్చుకోవాలి. It is not possible to learn all these things in the classroom. So a person like me cannot teach all these things. So that is why industry is far ahead. They are running, like we are just crawling. We are crawling. We are not even walking. We are crawling. They are running very fast. So కాబట్టి మీరు ఇండస్ట్రీలోకి వచ్చేప్పటికి, so whatever I have been talking to you in the class, that is not sufficient. You need to spend your own time. Okay, guys. So let us have these words, these keywords, I already used in one way or the other in my programming when I was giving you demonstrations related to different aspects in Java. I explained you all these three keywords. It's not actually like explaining. I used it in my programs. I used all these three keywords in my programs, but we are just going to delve deeper. We are going to have a deep dive into these three keywords because they are fundamentals. Just like you got object, class, instance. So these are all actually the jargon. This is jargon, technical words in Java. So these three keywords are fundamentals in Java. So without knowing these three keywords, it is not possible for us to write the programs and develop the applications. Now, the very first one is static. I have been using this keyword right from the beginning. I explained you through how to use this keyword for variables and for methods and everything, but we are just going to revisit, okay? The static keyword in Java is used for the memory management mainly. So this is used for the memory management. What is the significance of static? Is to manage the memory. So memory is actually a resource. In computing, memory is a resource. Processor and memory, processing time, processor and memory. Why? Because the processor consumes electricity. When processor is on, the electricity, you don't understand, the importance of processor in general purpose, I mean, in programming. But if you are a blockchain guy, or if you are cryptocurrency mining, they call it as mining. They mine the currency in blockchains, just like in our, we use money in our society, right? But people in blockchains, that is a network. Society is a network of individuals. The same fashion, blockchain is a network of blocks. Very important. This is the primary purpose of this keyword is to manage the memory. Okay, this is what we have. We can apply static keyword with variables, methods, blocks, and nested classes. There are four use cases. Okay, we can use the static. We can convert a variable into a static. We can also convert the method as a static method. And so here, please be cautious. The static never means that it is constant. Usually in English, static means something which cannot change, unchanged. It's not like that. It never means that it is not. To some extent, it is. Why that was used? Maybe this keyword was used for different. It has different connotations. So one of the connotations is to make something constant, unchanging, unchangeable. So it can be used for variables, and it can be methods, blocks, and the block is anything which is enclosed inside the curly braces, nested classes, which means class inside the class. Okay, now there are all these examples are there. So here the static variable, if you declare any variable as static, it is known as a static variable. So we just have to define. We just have to write static before the name of the variable, then that becomes static. It is that simple in Java. The static variable can be used to refer to the common property of all objects. It's used for the common property, a property which cannot, some extent, cannot change. It is common, but which cannot change. Such properties can be defined with the help of this keyword static. For example, if the company name of the employees, college name of students, etc. These are all, yeah, company name is not going to change. It's unchangeable. And the student name cannot be, it is not going to, but ID may change. But ID is also not, it is quite against to the protocols of the in programming. Actually, the ID it cannot be changed because that will be there forever till the end of that life cycle, which means whenever the student enters it. So the company name, it cannot be changed. Student names cannot be changed. IDs cannot be changed until some time. The static variable get memory only once. This is actually the crux of the main aim of the static keyword. Not this changing, unchanging things, but once a variable is defined, the memory is allocated. That's all. It is freezed. The memory is freezed. We don't need to worry about changing paradigms of the class area at the time of class loading. So whenever that class loads and the class assigns some amount of it makes your program memory efficient. Yes, of course, that is actually the primary memory. Let us understand. Yeah, this is actually a small. This is actually the thing. I mean, suppose if we have a class student and there are 3 different fields. The first field is the roll number and the name and college name. Now here, you see, if you look at this, what happens if we don't define the, if we define like this, see here, if you look at this variable college, it is not static, it is just string. Now what happens, whenever a student class is initiated, called or instantiated, every instance is going to have a separate memory location for this college. Suppose if I define, see here, like S1, student. Now what happens if this is how we define, you see here, if you look at this variable, it has this is constant, it is not changing. The college name is not going to change. ITS is ITS, that's all. Or Geetam is Geetam, that's all. Or some ABC is ABC, it's not going to change. So we don't need to, make it default. This is actually a default data type. If you don't define a string and the access identifier is default, not the public, private, or so it is actually a food design. Okay, this is not the ones. If you know that value for a data variable is going to be constant, it is better to define that variable as static because it is assigned once. That's all. You don't need to be. If we don't use the keyword string here, what happens whenever this class is instantiated, a separate memory address is being created for this value, for this key, college. Okay, value ITS is. So suppose if there are 5 students, 5 memory units will be allocated for this variable college. Student 1, college. Student 2, college. So different addresses will be there in the memory for this variable. So to avoid that, so it is not an efficient design. That is not an efficient programming. So if somebody is an efficient programmer, so why do we care memory? Because it is resource. It is resource. Memory is not, it is a resource. Resources must be used. We need to have a meager approach. We can't be lavish. Suppose if you have money in your pocket, will not be lavish, right? We'll think. So how much need to be, we'll have a plan because it is a resource. So in the same fashion, memory is a resource, processing is a resource. We need to think about this processing capacity of the machine and as well as the memory available for processing. The processor, use the memory for accessing the material for processing. Now, this is actually the efficient way of writing the class student, roll number, name, and here you see static string college ITS. Now, you create n number of instances, it doesn't matter. There will be only one memory location for college because it is static. It is static. And there is a diagram I'll show you. This is how it happens. See, you have 2 different instances. They're called stacks. So when S1 is a student, S2 is a student, and this is a stack in the memory. And both of them are have the attributes are called fields, ID and name. But one attribute or one field, which is a college, is static, which has a unique memory address. Okay, this is actually the heap memory. This is stack memory. This is heap memory. Heap memory is used for the fields, and stack memory is used for the objects or instances. So each one is an object. S1 is an object. So this is a stack memory, and this is a heap memory. It heaps. That's why we call heap memory. Stack memory, okay, then now you got another field called college. This is actually a static, memory address. So this is actually the efficient design. So Java has all these strategies for programmers. So as a programmer, I have all these assets available for efficient. This is actually the efficient way of writing the programs. Then you can ask me a question like, sir, why do we care all these things? Like, when the system, I have a lot of memory with me, that you may be having memory and you may be having a good processor. It's not the case. None of us have the good processors, and none of us have the as much memory as it is required for our programming. It's not true. But if you still think like that, but the language need to have this type of these strategies, and these strategies help for the efficient and dynamic programming, which may not be required for a data analyst, but for somebody else. Like, say there are certain domains like cryptocurrency, and there are areas like deep learning. So the machine learning is not important. Are there? Yeah. Are you listening to me? Kids are calling me and hello. Hello, are you all there? Do you all hear to me? Hello guys, are you all there?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So I just got a call and I thought I'm disconnected to you all. So it may not be important for us, but it is very much important for some of the individuals, like who are engaging in some very important fields like deep learning, not machine learning. Machine learning is easy, but deep learning requires a lot of processing. You don't. I think when I was teaching this machine learning to PGDB students, not now, I think in 2018, it was not possible for me to teach them CNN, convolutional neural networks. You know what happens actually when I start processing the data, my computer stuck. It was just 4 GB RAM capacity machine. It had at that time. Right now I have 16 GB RAM machine, but in those days I used to have the 4 GB RAM. So RAM was very important for processing. My processor was not happy with 4 GB RAM machine. So these things, after all, I was an academic, right? I was not writing the program for the clients. I don't have any clients. I am not into the industry. Only for teaching. I was not able to teach, convolutional neural CNN to my own students. Why? Because I was not having a good machine. So these strategies, you may think that they're not important for students. As a student, it is not important. But when you go to the industry, you don't know where you will be and where you will be using all this, logic. There you require, this type of strategies, the static type of, memory management and processor management. These are all very, very important. Now, there is another, the use case here, like, counter. Suppose if I use a variable count, a class, this is actually a class counter in which there is a variable count, which is initialized. Now the initial value of the count is 0. And now this is actually a constructor. You see in constructor there is a logic. And what is that logic? It's an increment. Now a count plus plus is going to increase 0 to 1. That is how the logic is going. That is how the logic is defined in this. This is a constructor. This is not a method. Please be cautious. The method is the constructor. You see the name of the method is same that of class name and the method constructor name. So this is how we already had this discussion constructors in one of the classes. So in this constructor, there is a logic like it takes this variable count and then increments, and now system and then count. Now let's say for example, if we create 3 different instances objects for this constructor, this class, say suppose we have C1, C2, C3, and then in class లో నేను చేస్తానులే చేసేసి మెసేజ్ ఇస్తాను ఇప్పుడు ఇస్తాను అయిపోయింది క్లాస్. So when we create the object C1, C2, C3, okay, counters, we are going to, so what is going to happen? Now you see the value will be 1, 1, 1, 1. So each time when we create an object here, and this logic is executed, and it is incremented to, 0 will be converted to 1. And now, see here, in this C1, it is 1. And when we created another object, it's still 1. Because the value is not static here. You see here, it is just a default value. It's not static. Now, suppose if we define the same, like, static int count 0. Now see what is this going to be. Why this happens? Because this count variable has a unique memory allocation, unique memory address. Memory is allocated distinctly to this variable. Now, this count is going to be 1. When C1 is created, it increments, and now the value of the count is 1, which is static. And now when C3 is created, now it has a different value. So here, the learning is static variables are class level variables. So static variables are class level variables. Whenever you create a variable which is static, it is going to manipulate in the class level, not in the method level. Not in the method. It's just going to reset. When 0 becomes 1, it resets the instance level information, not instance level information, class level information, not the instance level. Here, instance level. So this 0, this count is only instance level because it is not the static. It is only instance. Now this count is 0 in C1, count is 0 in C2, count is 0 in C3. But whereas here it is not like that. The count is 1, 0 in C1, and it becomes 1. And when C2 is created, the 1, it is 1, it is not 0 because it is static. Now this is so whenever we create a variable within a class, it is not the instance level variable, it is a class level variable. You are manipulating the data of the class, not the instance or the object. This is not the information available from the C1. It is information available from this counter 2. So this is actually the learning. That is the specialty of this. Now methods. These are all actually the variables. So how are you going to deal with it? It is also possible for us to define the methods as static. Class student. So there is a roll number and name, and now static, it is a variable. Now you see here there is a method called change. Now this method is static. Hello, am I clear what I'm talking, or am I just talking to myself? Hello, can somebody, Ram, are you all following what I'm talking?
Yes, sir, following.
Till now, I was just talking about how to take care of variables. Now I'm talking about method. Now here there are two variables or fields, and there is a method. There are 3 variables and there's a method. Now here the variable college is static as I have told you a couple of minutes ago. So whenever there is a constant value to a variable, just please better make it static. Don't define with default data type. Define it as a static data type. Now the method, there is a method called change, and it is static. How is this going to happen now? Now the same college. Now whenever this method is called, this is called the method call. So whenever this method is called, this call is a technical word. It is not just like using. I don't mean call in synonymous with using. It's just whenever a method is called, this name is going to change like this. It's just going to set another value to this key data. Now this is a constructor, but parameterized constructor. This is a parameterized. This is here it was actually the default constructor. This is default constructor. There aren't parameters, but here there are parameters. Here there are fields, and there is a method which is static. This is a constructor. So there is a method, there is a constructor. So in constructor, in class level, what is happening? You see, please be cautious here. Here the field is roll number, and here you see it cannot be roll number. Whenever we are creating a constructor, it needs to be something else. A roll number need to be R. If you are using the same, then this is not going to work. That is what I'm telling you. We need to practice. Practice makes you perfect. Example, there are 3 fields: roll number, name, and college. And there is a method. And the method college is equal to something else. And college is already defined, which is static. And you don't need to once again define inside. Now, when we come to the constructor, please be cautious. The constructor, this is student is a constructor for the class student. Now int r, this is int roll number. You cannot write int roll number. If you write int roll number, you have to use a keyword called this. That is for the next discussion. Okay, that is for the next discussion. That is not, I did not discuss with you. So int r string n, it is not the name. Now this is actually the constructor for this class. Okay, now why display? This is a method. This is a void method. Why we just wanted to print out roll number, name, college, which was set here. ఇక్కడ మనం సెట్ చేస్తున్నాము దాన్ని ఇక్కడ ప్రింట్ చేస్తున్నాం. Whatever we are setting here, we are just getting them here, getting and setting. Now student change. You see in main method first itself beginning we changed it. Now what is actually, so we can also do that in a different way. First we can call it the student dot college. Then we have to see what it is going to print. I'm sure it prints ITS. And now when we initiate this method change, this ITS changed to BBDIT, something like that. These are actually North Indian college names. I have to change. I copied this information from one of the blogs. As I said, I'm not the creator of all this information. The student change. Now there are three objects, S1, S2, S3, and then you got the display. You're all displays. Now what is going to happen? You see here, we use the constructor here. We are using constructor whenever we are, this is a parameter. When we are instantiating or creating the object, we can use parameters because there is a constructor. So this object is going to be created through this constructor. Now it was 111 something like Karan or whatever is ADC Karan, but this is coming from this method. Now what is happening here is this college is a static. We are changing that static variable with the help of a method called change. Now when we implement this method, this is going to cause the change in the class level variable. So this method is going to set up the value for the class level variable, which is static. That is the advantage of using the keyword static. So in all these three, since we are setting up the value in the initial phase, in the beginning itself, we are changing the college variable with the help of this method. Now it is no more right here, it is BBDIT, and this value is called through these objects S1, S2, S3. So when we call this display, now it is no more ITS, it is BBDIT. So that is why there is a change in college name. So if you want to change a static variable, so you need to have a method. Or you can even you need to have a method, or you can, but whenever some change happens in the static variable or static method, so that will change the entire definition of the class, not the instance. This is instance. S1 is the instance. It's not the instance level change, it is the class level change. This is what you need to keep in your brain. Okay, this is another example. This is just a method, like there's nothing so special. It is also possible for us to define the methods for calculations. Here, if you observe static in cube, and it is going to return, the cube of a value. And now system out println result is calculate a cube 5. And now what happens? Maybe I don't know. Like if we have a constructor, if it is a class level, it is also possible for us to define the value, and if you recall that value from the method, it will print. The answer is going to be the 125. And then block, it is also possible to define the block. Here you see static, and it is a block. It is neither a class nor a method, and not a variable. It is a block. So static can be used for the variables, can be used for the classes, and can be used for the blocks, and also for the constructor. Static block, and in this block, you see you got a print statement. This is a class. And in main class, when you call, so when you static void main, and you can just simply hello. So this is just going to print. So in main, we don't have explicit statement. We have not done anything. So when you execute this class, it automatically prints this statement. The block is invoked or something like that, and then it executes this statement. Because this is a static block, it automatically will be executed. And then comes this keyword. Okay, so I'll stop here. I'm sorry, there was a power, I mean, my system got shut down abruptly amid of the class, unknown reasons. And you just go through this, this keyword as well. Super is very interesting. Okay, this keyword, we already had some discussion on this keyword. The issue which I was talking about, you cannot use same, like when there is a roll number, you need to use, that is because that can be resolved with the help of this keyword, see here, like this. See here, there is a roll number, there is a name, there is a fee. And if you want to use the same names as arguments, then we need to use this. If you don't want to use this, then you need to define that method with different arguments, just like this. Okay, that is the importance of the. So this refers to this. The word this refers to object. Please be cautious. Static is for the class, and this is object, not for the class. So this roll number is going to set this roll number to the object, not to the class. That is actually the difference between static keyword and this keyword. And there is another keyword called super. Okay, you just try to read it. Super is useful to get the assets of the parent. It is used most of the time in inheritance. So when you have a parent class and a child class, in order to access the assets of the parent class, we use extends, and there it is possible for us to use the keyword super. So here, if you observe very carefully, the parent class has got the property white, and the child class has got the property black. And now this method prints both. Suppose if I want to print the field or the color of the parent class, then I need to use super. Otherwise, what happens? It is this retrieves the information from the child. You just read this, all of you. It is very easy. You don't need a class for this. So in my next class, I straight away go to the inheritance. Okay, that's